You think you've got TypeScript and React down, right? But let's be real. You're probably sneaking in any here and there, like a dirty little secret. The result? That stomach-dropping moment when your app crashes in production because any let a bug slip through. And that awful creeping dread when you command-click a prop and find yourself in Node modules with no type info to guide you. What if I told you there are just 7 quick and actionable patterns to help fix that? Stick with me, and you'll never have to ship a loose component again. Seriously, your future self and your teammates will thank you. We're going to zoom through 7 super practical micro refactors. These aren't theoretical academic exercises. They're snippets you can literally copy and paste into your project. No endless philosophical debates about type theory, no 20-minute detours into obscure language features, just solid, production-ready code that will instantly level up your codebase. Your teammates might even wonder if you secretly hired a ghostwriter to help clean up your act. You know the drill. You've got a component that can render in slightly different ways. Maybe an alert that's either an info or an error. What happens? You slap on a Boolean is error flag and then add on a bunch of optional props, like retry handler. Suddenly, your component's props become this tangled mess of constant if checks. Instead of you playing a guessing game, let's let the TypeScript compiler handle this for us. This pattern is called Discriminated unions, and it is pure magic. You see how if the type here is info, the color must be blue, and there is no retry logic in sight? But if the type is error, the color has to be red, and the retry logic is absolutely required. The compiler enforces this for you. It's not just elegant, it's bulletproof. Consumers of your alert component literally cannot create an info alert with a retry button. The compiler will simply just yell at them. One elegant type definition just wiped out 3 potential runtime bugs and saved you from having to write unit tests to catch them. How many times have you been in a component like this that fetches data, you get back your JSON, and then you slap on a use state of type any? With this pattern, you're right back to doing optional chaining with data.map everywhere, hoping for the best. It's like building a house with a blindfold on. Instead of this, we can create a generic fetch hook that looks something like this. We're telling TypeScript, hey, whatever data comes back from this URL must conform to this type T. We lock down that shape right at the hook's boundary. So now when you call your useFetch hook, TypeScript knows your data is going to be always of your type that you pass it or null. No more guessing. You get full auto-completion for your array methods like map, filter, and reduce. And this optional chaining paranoia, gone. Your code becomes safer, more readable, and honestly, a lot more fun to write. Have you ever built a component that expects specific children? Maybe like a button row that should only contain button components? But then you go to use something like an array.map, and suddenly the item in your array is the any type again, causing you to fall right back to type assertions or just hoping for the best. It's a wild west of props out there. Let's bring a little bit of order to the playground. We can explicitly tell React what kind of children our component expects with something like this. With this type, TypeScript now understands that any children passed must be a button component or an array of them that accepts button props. The magic? You can now map over these children and confidently access their props without any as any or other typecasting. If someone were to try to slip in a div or a span into your button row component, TypeScript will throw a fit before they even hit save. That red squiggle will show up faster than your morning cold brews. Okay, let's say you're going to wrap a third-party component. Let's say it's a material UI button to add some custom styling or default behavior. What do? Meticulously copy 10, 15, 20 props from the original component's definition? It's tedious, error-prone, and a total waste of time. TypeScript actually gives us a superpower here. It's called component props. We can literally steal the prop signature from any React component, including those from third parties, with something like this. Using component props, we can say the type of the MUI button is what our button prop should be. Now, button props automatically gets all the props MUI creates. When you create a loud button component, you just spread P, which is the button props, into your MUI button, and boom, all the types are there, perfectly inferred. The best part, if Material UI changes their props or adds new ones, your loud button component will automatically update too. You only manage additions and overrides in one spot, keeping your code clean and up to date with upstream changes. Okay, let's say you have a bunch of icons and you want to render them dynamically based on a string name. So what happens is you end up with a union type that looks like this: home, or settings, or user. Every time a new icon is added, you have to update this union type and the map and potentially any switch statement that uses it. It's a recipe for chaos and forgotten updates. Here's a slick trick using asConst. We can define a single icons object where the keys are your icon names and the values are your actual icon components. This asConst type assertion tells TypeScript to infer the most specific type, turning those string keys into literal types. Then, with this little line, we can magically derive our icon name union type directly from the icons object's keys. When you add a new icon, you only have to update this object. Your icon name type here will automatically update, and any component or switch case that consumes this will know about the new icon, getting full type safety and autocomplete for free. It's elegant, maintainable, and seriously reduces your boilerplate. Now let's look at a reducer. If you're using reducers, think like the use reducer hook or redux. You know the pattern. You have a switch statement that handles different action types. But what happens if you add a new action type and you forget to add it to your reducer? Your code will silently fall through this switch statement, leading to unexpected behavior or that dreaded runtime bug. It is a ticking time bomb. The never type can be your secret weapon for making reducers foolproof. By adding a default case where we assign the action A to a variable typed never, we're telling TypeScript this code path should never be reached. If you add an action type to this action union and forget to add a corresponding case in your reducer, TypeScript will immediately throw a compilation error. It forces you to be exhaustive. TypeScript will scream at you until every action type is handled explicitly. It's like having a compiler bodyguard for your reducer, ensuring no action ever goes unhandled and no dead code can hide in the shadows. Forms, am I right? They're essential, but typing them can be a pain. How many times have you copy and pasted this into every single input handler across your codebase? Or worse, resorted to this e.target as HTML input, just to get rid of the red squiggles. It's repetitive, it's ugly, and it's prone to subtle errors. Let's streamline that event handling. Instead of repeating these verbose types, we can create a simple type alias, input change. Now, anytime you need to type an input change event, you can just use this input change type. But we can even take this a step further. We can create a small helper function like handle that takes the event and the callback function. This little utility abstracts away the e.target.value extraction and ensures it's always handled correctly. Now your event handlers become super clean. You just call this handle function, you pass it the event and the function you want to call. One simple import, 0 of these lies, and your form code looks much tidier and more robust. It's a small change, but it makes a big difference in developer ergonomics. All right, if even one of these patterns made you think, wow, that just saved me a debug session, imagine what a whole arsenal could do. I've put together a completely free cheat sheet with all of these patterns and a few more advanced tips. It's linked right down in the description. Go grab it, print it out, slap it on your desk. Consider it your personal compiler bodyguard checklist. So there you have it, 7 powerful React TypeScript patterns. We talked about smart unions for props, flexible generics for hooks, strict children for components, how to steal props like a pro, freezing your icon maps, making your reducers truly exhaustive, and tidying up those event handlers. These aren't just theoretical concepts, they are immediate upgrades for your codebase. Plug them in today, and I promise you your next pull request won't just work, it'll ship with a whole team of compiler bodyguards, catching errors before they ever become console.error messages. Which one was your favorite? Let me know down in the comments below. And if you're into types that actually protect you and don't just exist for decoration, do me a favor. Smash that like and subscribe button down below. I'll see you in the next one.